Hey, good morning. All right, today I'm going to do some problems with molar mass and Avogadro's number. The first thing we need to do is going to be molar mass, and basically, molar mass is just calculating the average atomic masses of everything that is in the compound. For example, if I have silver chloride, I would know that there is one silver, one chlorine, and I would add up the appropriate masses. Look on my periodic table. I will see that this is 107.87. Chlorine is 35.45, and it is grams or atomic mass units. If I add these together, I will get that silver chloride has a molar mass of 143.32 grams, or AMU in this case. Okay, let's try one that's a little bit different. Molar mass is really, really easy. You shouldn't have too many problems with this. Let's look at lithium oxide. I notice that there are two lithiums, so it'll be 2 times whatever the molar mass, whatever the atomic mass is on the periodic table, which is 6.94, and I will add that to one of these, which is 16.00. I get a mass of 29.88 grams as my total, and that is molar mass. I simply take the formula, see how many of each are there, look at the atomic mass on the periodic table, and then add them up. That's molar mass. Let's figure molar mass and moles and do some calculations. If I'm given a problem that says that I need to calculate the mass of 0.467 moles of calcium bromide. Okay? Calculate the mass of 0.467 moles of calcium bromide. In order to solve this, I need to know a couple of things. I need to know the molar mass of calcium bromide, and I need to write down that they have given me 0.467 moles of it. So let's go ahead and start this. 0.467 moles of calcium bromide. Okay. How much is 1 molar mass of calcium bromide? Well, I notice that there is 1 calcium, which is 40.08. I notice that there are 2 bromines, so 2 of those times what the molar mass is. Bromine is 79.94, I believe. Let me double check. 79.90. Okay. If I add these two together, calcium bromide has a molar mass of 199.88. Okay, 199.88, and that's grams per mole. So, CaBr2 is 199.88 grams per mole. That's going to be the conversion that I use, the conversion factor. So write down what they give me, 0.467 moles of calcium bromide. Put a times sign because you know you're going to have a conversion factor. And draw this. Now, I have this. Calcium bromide is 199.88 grams for every 1 mole. I can put either grams or moles on the top or bottom. In this case, I have moles on top, so I'm going to want to put that 1 mole of calcium bromide is on the bottom. That way I can cancel out moles. And at the top, I'm going to put 199.88 grams of calcium bromide. What I'll do is that if I notice, I can cancel out moles of calcium bromide. I am at grams of calcium bromide, which is what they ask for, which is looking for the mass. Put my equal sign, and in my calculator, I'll just put 0.467 times 199.88, and I will get an answer. 1 second, let me double check. And I got 93.34 grams of CaBr2. Hopefully that is correct. 93.34 grams of calcium bromide. The trick with these is just to make sure we get the molar mass correct, and to make sure that we have our units canceling out as appropriate. So let's try another one. Let's do one. Calculate the mass of 5.634 moles of HCN. Okay, I will give you just a second to set this up while I do my own work on the side. Give you about a minute and then I'll get started. Okay, let's go ahead and start working through this problem. As you notice, I went ahead and wrote down what they gave me. They gave me 5.634 moles of HCN. I need to figure out the molar mass of this compound. There's one hydrogen, which is 1. There's one carbon, which is 12.01. And there's a nitrogen, which is 14.01. If I add all these together, I get that this compound has a molar mass of 27.02. So I know that 27.02 grams of this compound is 1 mole of this compound. Now what I need to do is find what they've given me. I've already written it down. Put my time sign. I know I have a conversion. I can either put moles on the top or moles on the bottom. Since I have moles on the top, in order to cancel it out, I need to put the molar part of this equation, this conversion, on the bottom. So 1 mole of HCN on the bottom, 27.02 grams of HCN on the top. I will notice then that my moles of HCN have canceled out and I'm left with grams, which is what I'm looking for. So therefore in my calculator, 5.634 times 27.02, and you should get a total of 152.2 grams of this compound. And that is molar mass and converting from moles to molar mass and vice versa. Last thing I want to do is Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd atoms, molecules, okay, of anything. So 1 mole of anything is this many atoms or molecules or particles, whichever they ask you for in the question. Alright, that's Avogadro's number. And in order to use it in a problem, let's go ahead and take a look at 2. Let's just say, for instance, that we are given 2.57 times 10 to the 11th atoms of silver. And we are asked to find how many moles of silver that is. Alright, what am I going to need to solve this problem? First off, I know that I'm dealing with atoms, so automatically atoms means I'm going to have to deal with Avogadro's. Period. End of story. You see atoms, it's Avogadro's. So I know that I can go from Avogadro's number to moles. 1 mole is 6.022 times 10 to the 23rd atoms of anything. So all I need to do is write down what they give me. 2.57 times 10 to the 11th atoms times 1 mole over 6.022 times 10 to the 23rd atoms. Here I see that my atoms have canceled out. Now I'm at moles of silver. And if I do my calculations correct, in the calculator it should be 2.57 EE. Use EE in your calculator, and it works better for this. 2.57 EE11 times 1 divided by 6.022 EE23, and I should get a number that looks like 4.27 times 10 to the minus 13 moles of Ag. Okay, what about the other way? Let's go from moles and let's go figure out, let's see, if I have 0.0524 moles of water, and I want to know how many atoms of water that is. Okay, write down what they give me, 0.0524 moles of water. And if I come over to the side, I know that 1 mole of water will always be Avogadro's number, 6.022 times 10 to the 23rd atoms of water. Okay, all I need to do is put this in my conversion. I will put my mole at the bottom so it can cancel out. I will put my Avogadro's number at the top. I am at atoms, which is what I needed. All I need to do is 0.0524 times 6.022 times 10 to the 23rd divided by 1. Moles have canceled out. I'm at atoms. And my final answer should be 3.16 times 10 to the 22nd atoms of water. And that is it for my presentation. Thank you.